David, good afternoon, everybody. I hope you're all well. Welcome once again to the Commit Happy Hour as the close of the, I think this is probably the 9th week we've been running these sessions. So today we are looking at some of the new innovations and thinking around reducing the damage to underground utility infrastructure during excavations. It's something that I think costs our industry a hell of a lot every year, and also can cause a lot of safety issues in that area. So what I'm going to do before we start on that is I'm going to hand you over to Stuart to give you a little bit of an update about the COMIT2 Productivity Group, and also how you ask questions and how we will go about doing the conversations afterwards. So over to you, Stuart.
Okay, thank you, Ian. Thanks to everybody for joining us today. Thanks to our panelists, and thanks to the contributors to make today happen. Before I get into it, I want to just cover a very important aspect, and that's about how to ask questions. First off, the control bar, there's a red arrow at the top. If you want to minimize that so you can see the full screen, just click on it. It should actually drop down automatically, but if it doesn't, the red button. Questions wise, you've got two options. You can either type them in the questions bar, which you see on the right hand side, or alternately you can raise your hand and I will come to you afterwards, and I could invite you in. We can open the mic and you can speak directly. Now that can be with or without the webcam. We do have the session question afterwards as well, so you could actually participate in that. And we've got another area where it's a fairly relaxed, continue the conversation, chat with the panelists and anybody else that's involved. So that's how to do that. Now, just to move into the session, I want to talk very briefly about Commit to Productivity. It asks the question, what does productivity mean to you and your organisation? Do you have the actual means to improve productivity? And what else is out there? We try to bring some initiatives and share those with the community and the wider participants to show what's making a difference to businesses and organisations and how it can help you. And we do reach outside of just the construction industry. We go to other industries and bring in sort of points of learning so that we can advance. If you have any topics that you think would be worthy of involvement and participation, then do again get in touch and share what you have. Now, what we have been doing is we've been looking at various areas, and the Commit to Productivity covers a lot of the areas that you see on the screen. And we've covered several areas, aspects through project controls. We've looked at safety. We've looked at emerging technologies. We've looked at planning, and today we've got one area which looks at reducing damage to underground services. Now, Jeff shared a slide of mine, and he's put that under the heading of others. Now, it's a fairly vital part of construction. You know, if we can avoid damage to services, it can save a tremendous amount of cost and schedule time. So, just moving on the reducing damage to underground services, I want to just share a little fact with you about how much cost there is associated with damage to underground services. It's estimated that the cost of accidental strikes and on underground pipes and cables is approximately £1.2 billion per year. Workers who hit gas and electricity pipes by mistake can also put themselves in danger of death or serious injury. There is currently no comprehensive underground map of the UK's service network. Different organisations have their own maps showing where such things are as pipes, electricity cables, telecoms, but the lack of combined map creates an increased risk of potential and lethal accidents. To help prevent such accidents, the government has announced its ambition to bring together the existing data on underground pipes and cables to create a database. When workers strike pipes and cables, it does risk lives, it costs money and causes havoc to residents and road users. So with that in mind, I've got one slide I want to share is this particular one. Now, it sort of highlights the fact this is an electricity cable, and I believe it was 11 kV, but there was nobody injured or harmed in the making of this, taking of this picture and creating this scene. It was a dummy that was used for training. But it highlighted the effect of what happens when you strike a cable mistakenly, and it does happen quite a lot. Now, I'll also share the next slide as well, which I'm not going to say anything about this. If there's time at the end, I'll mention my little Russian doll story from way back working in the civils market, installing new infrastructure. But I'm saving that till the end if there's time. First off, I want to run some little poll questions past everybody, and if you just bear with me, I'll launch the polls. We have 3 polls with multi-choice answers, and this is my first one. As an employee or contractor, which do you work for? And there are options, multi-choice options there. Okay, can everybody see those?
Yeah.
Okay, great. Okay, I think everybody's voted. Pretty much everybody's voted. Thank you for that. Let me share that now. Okay. So 70% utility or telecom, 28 engineering consultant, 41 construction, 7% government, 7% transport infrastructure. Any thoughts on that, guys?
Well, I'm not surprised really, because I think this is very important to those construction contractors who are working in this area. I think they probably have the biggest impact on this. And yeah, I mean, following up on that, I would have expected to have the utility telecoms company being the next most interested company there, but it seems to be consultancy as well. So yeah.
Yeah. Okay. Thanks, Ian. So the next question I've got here in your work is knowing the accurate location of underground utilities and telecoms. Well, there's 4 multi-choice questions. Important, very important, nice to know, unimportant or irrelevant. That should have launched now. Thanks to Jeff for helping develop those questions, by the way, or these questions. I'm really pleased about the way this poll's going. Goodness.
I can only presume those who feel that it's irrelevant are not those people putting a spade in the ground or potentially taking any sort of risk whilst doing that sort of excavation.
Sure. Yeah. Jeff, any thoughts on that? No.
That is very interesting. Yeah, I mean, this obviously there's a lot of people who are interested in this topic.
Yeah. Okay, and the third and final question. Are you aware of the following technologies for detecting and locating underground infrastructure? And we have multi-choice again. So everybody should see that now.
I've not come across inertial mapping for this yet, so I'll be very interested to hear what that is and how it works. The others, I think if anybody here was ever brought up on Time Team on Channel 4 back in the 90s, they'll know about electromagnetic and ground penetrating radar. They were pretty standard for the geospatial team. Yeah.
Okay, let me share that with everybody. So we've got 88% electromagnetic locating, 94% ground penetrating radar, 22% inertial mapping, and of course the latest one to line up is generating accuracy with mobiles, 44%. Yeah, well, thank you very much for replying on that. Any thoughts from the panelists?
Yeah, I'm very interested that almost half are aware of generating centimeter accurate as-built with a smartphone.
Yeah.
Because that is pretty recent technology.
Yeah.
I'd also be really interested in how that data that's accumulated is managed.
Sure. Okay. So let me jump on to. Thank you very much for participating in that one. Let me just jump into the intros. So on the main session today is Jeff Zeiss. Jeff is the principal for an organisation called Between the Poles. Jeff's very kindly agreed to present today on his facts, findings, and knowledge. Jeff tracks the contribution of geospatial technology to the digitalisation of construction and energy industries in his Between the Poles blog, LinkedIn and other media. His areas of special focus are mapping underground utility infrastructure, BIM and geospatial interoperability for full life cycle of construction projects. From 2014 to 2016, Jeff was editor for Energy and Building with Geospatial Media. Prior to that, Jeff was responsible for thought leadership, evangelization and industry messaging for the utility industry program for Autodesk. Second is Russ. I'm going to follow up with Russ after Jeff's session, and I'll introduce Russ then. But we've also got Katie, who's going to join in the panel discussion at the end. I'll introduce Katie then too. So without further ado, I'm going to hand over to Jeff. Just bear with me a second. Hand over to Jeff. Jeff, you should have control now. Okay.
Yep, I should have it.
Thank
Is that
you.
okay, Stuart?
That's great. Thank you very much. Yes.
Okay, great. Thank you, Stuart, for that introduction. That was I think it was a very good, 15-second overview of the problem that we're facing when it comes to underground utility infrastructure. What I'd like to do is I'll start off with just giving some information about how serious a problem this is. I'll put it in the context of construction productivity, because that's what COMIT is all about. And I think that what is going on in construction right now is people are expecting a serious sea change to happen in construction, and it's going to basically involve digitalization of construction. And a lot of what I'm going to be talking about today is going to be talking about digital technology. So this is the slide, my slight modification of a slide that Stuart just showed, showing that addresses construction productivity. I've added damage prevention during construction to this, and I'd like to make the case today that one of the areas that I would even call it a low-hanging fruit, that if you really wanted to do something that would impact construction productivity quick, would be dealing with underground infrastructure. And I'll give you some statistics to back that up. Then I'll go through the cost of this, and this is financial cost, but also the cost, social cost of hitting underground infrastructure strikes. I'll talk a bit about some of the new technologies, which we've already brought a few of them, and I won't have all of those on the slides. I just don't have enough time to do that. This is an area where underground infrastructure is an area where there is a lot of new technology being developed by startups and by well-known companies like Leica Geosystems and Sensors and Software and so on. I'll talk just briefly about an ROI study that estimates the benefits of improving the information we have about the underground, and then I'll talk about a white paper that I just published with a colleague of mine, Dr. Shinowaki, in Japan, and we'll talk just briefly about two jurisdictions, Japan and Heathrow, where they have been very successful in reducing the number of incidents of underground damage. So I think most people on this call will know that construction productivity is a huge problem. Basically, over the last 40 years, while general industrial productivity has improved by a factor of at least 2, construction productivity in many countries, including the United Kingdom, Germany, Japan, US, quite a few of the advanced economies, construction productivity has either plateaued or stayed constant. So let's talk about utility strikes. This is just an example, but this is a very interesting example. This is an extension to an LRT in Australia. Before the construction began, they spent about a year trying to discover all the underground utilities that were in the right of way. And the interesting thing was that during construction, they found another 400. And this is not atypical. This is the kind of problem that is responsible for the fact that a lot of construction projects are over budget and over schedule. In this particular case, they actually contracted a consulting firm to come in, and the consulting firm to do a study of this, of what the benefits would have been if they had had a 3D map of underground infrastructure at the beginning of this project. And this was a 5-year project, and they estimated that they could have finished this project a year and a half earlier if they'd had good data. And I could give you other examples, but I just don't have time to do that. Another really interesting statistic about this, that in the US, over a period of 2 decades, underground utilities something over 400 people death, and nearly 2,000 injuries. If you look at the statistics over a similar period, 2 decades, for the US commercial aviation, the number of people was slightly over 400. If you look at the budget in the United States, it's on the order of $20 billion a year. If you look at how much money is devoted by government, for example, to underground utility damage, probably the best estimate I would come up with would be from PHMSA. I'll come back to what PHMSA is a pipeline safety organization in the United States. And their budget is around $230 million. So the amount of effort that has been put into aviation accidents is incredible, but it has dramatically reduced the incidence of aviation accidents. The cost of utility strikes in the UK, this is a study done by University of Birmingham. You can see that it varies for different types of underground infrastructure, but it's on the order of 1,000, roughly on the order of 1,000 pounds. That would be probably roughly what the estimate is. But these are only direct costs. So this is just the cost that it's going to be. These are just the costs that are going to be incurred by the water utility, or by the telecom, or by the gas utility to fix the problem. Other research at University of Birmingham have estimated that the indirect costs, which would include social costs, traffic disruption, loss of custom, things like that, are on the order of 29 times the direct cost. And I've used that to actually try to estimate what the total cost to the economy is. In the United States, there's an organization called the Common Ground Alliance, which collects statistics. These are voluntarily submitted statistics on strikes, underground utility strikes, and putting that information together with the information that from the University of Birmingham, for example, leads to an estimate of something between $50 and $100 billion annually to the U.S. economy. It's a little harder to do it in the UK because there is an equivalent organization, but it doesn't have the statistics yet that the Common Ground Alliance has in the US. But I think everybody, as Stuart mentioned, and I think everybody believes, it's probably at least 1.2 billion pounds. Some estimates say it's 6 billion pounds. It may be significantly larger than that when you include indirect and social costs. In the Netherlands, there's fairly good statistics, and the Dutch economy, it's probably costing them something on the order of €1 billion a year. So this costs a lot in lives, injuries, and financial costs. It's instructive to compare the number of incidents in the United States every year with those in Japan. As I said, the low estimate is on the order of 400,000 incidents in the United States. That's basically one every year, one every minute. The Common Ground Alliance their error bars will say that it's somewhere between 400,000 and 800,000. So it's 1 or 2 per minute. And in Japan, in 2016, there were 134, and I'm not leaving off any zeros. I mean, this is like 5 orders of magnitude difference between what happened in Japan and what's happened in the United States. And I'll come back to this, but basically, Japan had a serious incident in Tokyo around in the early 1980s, and since then they have had a well-funded program to reduce the number of incidents of underground damage. So something can be done, and that's the main reason for showing you this slide. It's not something that this is a problem everywhere in the world and nothing can be done about it. And I'll come back to not only has Japan done something about it, but Heathrow Airport has done something about it. So let's talk a little bit about the technologies we touched on briefly. One of the really most important advances is the fact that now you can tow ground penetrating radar array behind a truck in a van at roadway speeds. This is an example. Impulse Radar, which is a Swedish company, they can capture ground penetrating radar scans at up to 130 kilometers an hour. This is huge. It improves safety. It requires a lot of post-processing back in the office, but it means there's no boots on the pavement. Another thing that's happened recently is that software has to be developed to simplify the interpretation of GPR scans. If you've seen a GPR scan, and I'm showing you one here, it looks like hyperbolas. And this generally requires an experienced geotechnical expert to interpret this. But Leica has developed software now that actually doesn't show you any hyperbolas, just shows you what you would recognize as a tomographic display, which would be the kind of thing you might see from an X-ray or an MRI, for example. This is the inertial mapping. This is from a company called in Belgium called Duct Runner. They have different sizes of devices with batteries on board and memory on board that can traverse underground pipe networks for up to 2 kilometers and capture the location accurate to plus or minus 15 centimeters in both X, Y, and Z. The result of this, once the memory is retrieved and downloaded, is the result. The result is a 3D model that can be exported in AutoCAD or KML format. This is the example I gave. This is from a company called AVUS, which is actually based in the UK right now. They have been focusing on newly installed infrastructure, but basically using control points or RTK base stations, for example, they're able to capture, just using a smartphone to capture a video as built, accurate to plus or minus 5 centimeters. And they are also using this process to capture the location of utilities that are exposed during excavation to correct some of the as-builts that are in error. Augmented reality, mixed reality, different terminology for this AR, MR allows you to actually see underground infrastructure on a mobile device, and it allows you to actually identify the actual location and also distances between things as well. And it allows you to integrate traditional GIS and BIM, CAD, other types of information into a 3D augmented reality view on a handheld. This is another area that is really getting a lot of attention. We already talked about NUAR, the effort in England to develop a national underground asset registry. This is an example of a commercial system. This is being developed by a company called ProStar GeoCorp for the Colorado Department of Transportation, and it allows data to be brought in from a variety of sources and shared among government, network operators, and construction contractors. And in fact, in this particular example, the biggest supporter of this and one of the first users of this is actually a construction contractor, Kiewit, in Colorado. The data is then accessible to smartphones in the field and can actually be used to update incorrect data from the field. So this is a really interesting thing. I've only mentioned Colorado here. There's something similar in Montana, and I've mentioned also the fact that in the UK, the Ordnance Survey has developed a system very similar to this. So there are also standards for sharing information about underground and also for quality. This is an effort by the OGC, Open Geospatial Consortium, to share information about underground assets. And you can see there's a number of, it's based and designed to interoperate with other standards that already exist. There's also quality standards, and probably in the UK, the best known is PAS 128. Came out first in 2014, and it's currently under revision. I think it was made public. It was made available for public content in April, but that should be available very, very soon. There's also other standards in the US, France, Canada, Australia, and so on. This is the ROI study I mentioned. This was done for the Pennsylvania Department of Transportation, and they found that for every dollar spent on SUE, which is subsurface utility engineering surveys, that it saved $11. I have other examples where that found that $21 could be saved. An effort in Milan where 16 euros were saved for every euro spent. But I think it's obvious that there is a tremendous ROI for investing in improving the quality of the data we have underground. One of the areas that is getting a lot more attention now, and I've referred to it at the beginning, and that is statistics about incidents. In North America, there is no mandatory reporting of this except for transmission pipelines and some distribution pipelines of gas and fuel. So this is the Common Ground Alliance is a voluntary organization, and they get about 400,000 submissions every year, and you can see on this graph. And if you can't see it very well, you can get this slide deck and look at it closer. But they estimate that the number of incidents, as I mentioned before, somewhere between 400,000 and 800,000 per year. And if you prorate this to the amount of actual construction spending, the rate is actually increasing. In other words, there are now. For each $1 million of construction spending, there are more incidents now than 3 years ago. So this is not a good story. Things are not improving. This is something similar. Common Ground Alliance has different regional offices. This is from Ontario. I think this shows it even better. It shows you how the number of incidents is changed over the years since 2007, and you can see there was some dramatic improvement from 2007 to 2014, but since then it has been gradually increasing. So we are basically we have a problem where the number of incidents every year is basically the same. And I could show you some statistics also from the Netherlands that would show you the same thing. Unfortunately, I don't have good statistics from the UK. Now, just talking about, over the years, I've collected information from a number of jurisdictions, probably 20 years. This is probably over 20 years that I've done this. And you can see I've got some from the Americas, Europe, Asia Pacific. A number of organizations around jurisdictions around the world have tried to do something about this. And I'm going to talk, there are different ways that people have attempted to do this. Everybody's aware of call before you dig, for example. There's a call before you dig in England. There's CLIP in Belgium. There's CLIC in the Netherlands. Some of these things are government voluntary. For example, the vault system in Scotland is still voluntary. I think within a year it will probably be mandated. And there's government mandated systems in Japan. There's industry associations doing things like Common Ground Alliance and the Utility Strike Avoidance Group in the UK, and so on. So there's a lot of different ways of addressing this problem. It's not one size fits all. This is the survey that I mentioned before that was done in Japan to estimate just how many incidents there were in Japan. This is the survey that was done in 2016, and the statistics have shown that the number of incidents has been declining significantly since 1983, which is when they started collecting. And these are the key reasons why in Japan this has happened. First of all, there's a high level of collaboration between highway agencies and utility network operators. This is a little bit of Japan Inc. And you know, Japan has a reputation for a lot of collaboration between industry and other organizations, including government. There is a system in Tokyo and the major Japanese cities, I think 12 altogether, called RODIS, that brings all the underground information together with road networks. The construction culture in Japan generates generally as-built with an accuracy of plus or minus 10 to 20 centimeters. Incidents of utility damage have to be reported, and there's regulations, business processes, and cultures which they have developed since 1985 that requires excavators to be extremely careful when they get within 50 centimeters of underground infrastructure. This is a map showing the underground infrastructure at Heathrow, and you can see there is a lot of stuff. There's 15 different types of network owners at Heathrow. There's thousands of contractors, and at any given time, there's probably 1,000 contractors working there. And it is high risk. If you hit something serious like a gas or a fuel line, you can imagine with the number of planes and passengers that are there at any given time, that would have a very high impact. And these are some of the reasons why they have been able. The graph shows you that they have been bringing down the number of incidents of underground damage over the years since about 2002. As I mentioned before, reporting underground services strikes are mandatory. They have a very complex 7-step process for excavators for excavations at Heathrow. They have exclusion zones based on the Pass 128 quality levels, which restrict what kind of excavation you can do depending on the Pass 128 quality level. And really important, and that is people involved in detecting and mapping underground infrastructures have to be trained and certified. And this shows you some of the statistics. The yellow shows you the number of strikes per permit. That's a permit to dig. And the green shows you overall construction activity. And you can see that they continue to bring the number of strikes down. This is the National Underground Asset Registry that we mentioned at the beginning. This has been funded by the Geospatial Commission, which was just created about 2 or 3 years ago. It was started with a £3.9 million allocated to 2 projects, one in the Northeast and the other one in central London. The one in the Northeast was in Newcastle. It started about 2 years ago. And was remarkable because they were able to bring together all the local utilities and the telecoms together with local government to work and share information. The Central London pilot started just a few months ago, but again, they were able to bring together the governments of city councils for 6 boroughs, 22 utilities, telecoms, and local authorities sharing vector and raster data, and both of those pilots were completed, and I would say successfully by March 2020, and will form the basis for the effort now going on to prepare an RFP for bid within probably by the end of the year. This is the utility strike avoidance group that I mentioned in the UK. This right now, there are 200 utilities and industry groups and contractors that belong to this. They are trying to do something similar to what Common Ground Alliance did in the UK, collecting voluntarily submitted incidents, but they only started in around 2013, so the data is not really comprehensive enough at this point. In the Netherlands, this is a remarkable system called Click Online, and it's basically the Dutch one call system. If you are going to dig somewhere, you can log on, you can define a polygon and say, this is where I'm planning to dig, and within 24 hours, you will have a map of everything underground in that area, from all of the utilities and telecoms in that area. So it's extremely efficient, and that's probably the biggest benefit of it. Unfortunately, the reliable statistics, they also collect good statistics, but the statistics have not shown that Click has actually reduced utility damage. And this is an important point. There really is no silver bullet for reducing utility damage. There are a number of things that contractors can do, that government can do, that utility operators can do, and other stakeholders can do to do this, but it really needs a comprehensive program. Singapore has implemented a standard so that anything new going in the ground has to be captured to plus or minus 10 centimeters. In the United States, I mentioned before, PHMSA covers a lot of gas distribution, but mostly gas transmission and hazardous liquids. It's mandatory to report incidents. Their statistics have shown that they've had quite a number of fatalities and a number of injuries, and actually estimated the total property damage is something on the order of $500 million. But I think the most important thing is that these statistics also have not shown, in spite of a lot of projects that PHMSA has implemented to improve pipeline safety, the data does not reveal that there has been a trend toward reducing pipeline incidents in there. So these are. For the white paper, I came up with a list, I and Dr. Shinoaki came up with a list of 25 different things that could be done to help reduce underground damage. And this is just a quick summary of them: reliable statistics, taking advantage of some of the technical advances we talked about, policies, procedures, legislation, regulations to improve accuracy, timeliness, and completeness. Making designs more sustainable, improving collaboration between network operators, engineers, contractors, project owners, other stakeholders, increasing the digitalization of the technology used to capture and share information about the underground. Data protection is critical because telecoms in particular, but other utilities as well, will not make their data available if it can be seen by the competitors. So this is a really critical item. These systems have to make access available to all stakeholders throughout the construction project, from planning, design, through construction to operations and maintenance. Liability is really key here. Who's going to pay for something when something happens? And in some jurisdictions, the liability almost always seems to lie with the contractors. There's other jurisdictions that have come up with shared liability models. France is an example. I mentioned in the context of Heathrow how important training and education is. And of course, there needs to be viable business models to support all this. The white paper is available online for free. You can go to the GITA site and you can download it. And it contains a lot more information about the technologies and costs and other things that I've mentioned on this presentation. So the key takeaways that I'd like to leave you with: first of all, productivity in the construction sector is a problem. One way that could be used to improve productivity in the short term is improving the location of our information about underground infrastructure, which is a leading cause of construction delays and budget overruns. We've talked a little bit about some of the new technologies, GPR at highway speed, inertial navigation, cloud-based systems for capturing and sharing information, and augmented reality systems for showing that. So I think the key thing I'd like to leave you with is that this is an area that is really capturing a lot of people's attention right now. There's a lot of technology being developed for this. There are efforts being made by departments of transportation, ministries of transportation to implement systems for sharing information about the underground. Thank you very much.
Thank you, Jeff. That was incredibly inspirational and a lot of insight there as well. Yeah, thank you very much for sharing that. I know we've got quite a few questions. I'm gonna just firstly introduce Russ before we get into the main session of questions. So just bear with me a second while I do a transfer over. Excuse me a second.
Russ, do you want to turn your webcam back on? Ah, there he is.
Over to you, Russ.
Can't hear you at the moment. You must be muted.
There we are.
That's better. The organizer had muted me. He obviously knew something that I didn't. So thank you. In a nutshell, I mean, Jeff really said it all, and it was a passionate thing, and all the data was there. For me, what I'm really interested in is a mindset and cultural thing about how we share the data. Getting the data is one thing, which is troublesome at best and almost impossible at worst. But when we do collect that data, how do we actually share it? I mean, fundamentally, if we don't share it, it's of no use. And a lot of these strikes come from fairly small, isolated incidents that apparently at first glance are not massively important. You know, and I have a little story myself. When I was working as a plant engineer, contractor was warned, as you dig around the plant room, if you find any clay drains, dig by hand, because you never know what a clay drain might contain. Obviously, the contractor and contractors generally think, and this was some time ago, it's easier to repair a broken drain than it is to hand dig around it. Unfortunately, this particular vitreous clay pipe contained a 30K power cable, which ended quite disastrously. So it's small incidents that cause us a lot of grief. But when you've collected the data, and I think every utility, everybody that opens the ground has a social responsibility and a business responsibility to record that data. It's as easy as Jeff was mentioning. You've got a mobile phone, take a quick video. I mean, as you probably saw from Stuart's introduction, I work from Bentley Systems, so obviously there are some software implications here, but I'm not going to lean too heavily on that. But you can capture from a mobile phone enough information to create a 3D model of everything that's in the ground very precisely, plus or minus 2 or 3 centimeters, as Jeff was mentioning. But the big problem is, where do you store it and how do you make it available? So, you know, some thoughts that I'd like to share is that in the UK, we have got the Centre for Digital Built Britain. And that really is the creation of a digital twin for asset information throughout the country. And every major city in the UK is developing its own set of digital twins. It seems to me the perfect opportunity to include utility information into a digital twin that can be easily shared through a relatively impartial group like the Centre for Digital Built Britain. I also think that there should be so much more value attached to the information stored, not just the location of utility, but how do we improve our infrastructure by studying how the utility network is built. And obviously, we have the unfortunate circumstance of our utilities going back decades, never recorded very well, and the surface topography has changed significantly, and location information that we have got is probably wildly out of date. So my suggestion is, every time a service is opened by a utility or a contractor, let's record it. whether it's their own utility or somebody else's utility, let's record it, but let's find somewhere where we can share it. So collaboration is key. And as Jeff mentioned, Heathrow, for example, and I can remember working on the Heathrow project way back when the first discussions of a common data environment and asset data management were discussed. So it's clearly a exemplar project where these utilities, the planning was there from the outset to record them and protect against strikes or misuse. I also mentioned misuse. It isn't just strikes. I used to work for British Gas. I spent nearly 10 years working for British Gas, and on one occasion I can remember that bad information left me connecting a ductile iron gas pipe to a ductile iron water pipe that also ended up in severe embarrassment. So we need to collate this data, we need to share the data. I don't know, Stuart, whether you can pop up my slides for me, or shall I do it from this side if I can?
Might be easier to do it from your end, Russ, purely to then you know what you're showing. There we go.
We'll have a go. Okay, so hopefully I'm showing.
Yeah, we can see that.
Okay, so let's just pop this up. So I just want to do this very quickly, just really to set the scene. So that's who I am. There's some pictures of me way back down in the trenches. So I feel as if I've got some kind of credibility in as much as I've been down in the trenches and repairing gas pipes with North Thames Gas when it existed so many years ago. And my experience extended to also some development work, and I own a patent for pipework connections. So really just to establish that I've been around a bit, I suppose, and that's by virtue of getting old. But mapping the underworld, it's incredibly important. And as Jeff said, there are so many ways that we can actually try and achieve that. And believe it or not, I have actually worked with a supervisor in the gas industry who took a pair of welding rods bent similarly, who reckoned he could divine for the location of a gas pipe as easily as any of the other technology. And to be honest, the quality of the results probably wasn't too much different. It was, back in those days, it was pretty hard to locate stuff accurately. But now we have the benefit of 3D technology and scanning systems, and we should do this. Every hole that's open should be recorded in this way. And if it's owned and managed by somebody like Centre for Digital Built Britain, it can be stitched together and you can end up with a pretty decent 3D network of what exists. Now, mapping the underworld is one thing, but capturing the underworld is another. And I've got a few seconds of video here that I think is really good. And this is as simple as all the contractors watching today, buy a GoPro camera and strap it to the backhoe of your JCB. So let's see if I can just run this little video as well. See if I can make this work. Okay, are we seeing the video, everybody?
Yes, we can see that.
Okay, there's sound with it as well. Let me just run this video. It's really quite
We haven't got the sound, Russ, but we've got the picture.
Yeah.
Okay, so what's happening here is that they literally attach GoPro cameras to important parts of the equipment, so you can see the ground being opened, and then a combination of laser scanning and photogrammetry produce images like this. It's fully dimensionable, and that's really it from that. So let me just drop that back again. So it's in my opinion, it's relatively simple to gather the data, but I think it's a huge thing in terms of getting the collaboration between the utilities, having somebody take the responsibility and ownership. I'm still amazed that we can send radio signals to Mars, but we can't actually get much more than a meter or two underground with any great reliability with any of our technology. I've got some ideas about that as well, but fundamentally it's who will take ownership, who will be responsible for, and what added value can we apply to the information gathered. When I worked for North Thames Gas, we used to take pretty darn good records, and they were stored in books on shelves in the drawing office. But we still had incidents where our own people would connect to the wrong main or dig up a different main. And when I said to them, why didn't you use the information that we got for you? They turned around and said, well, we just didn't have time to come into the office and look it up in a book. Even now, with the benefit of mobile devices and mapping devices on iPhones and iPads, it still seems to be a challenge. So I'll leave you with that thought. I'd love to be involved more, and if I can offer any ideas or anything controversial, I'd be pleased to do it.
Brilliant, thanks, Russ. That was interesting. It always amazes me that we don't capture more information, but I think it kind of goes back to the BIM world that I work in, is the fact that nobody does anything unless they're paid to do it, or they'll go to jail if they don't. So it's got to be backed up by some form of mandate, some sort of funding in the background. But yeah, very good. Stuart, have we got some questions coming in from the floor?
We have got some questions, and let me firstly introduce Katie as well. Katie's on the panel with Russ and Jeff. Katie's with Arup. Katie's a geospatial information consultant, and is a professional with 25 years experience encompassing national mapping agencies and the finance, defence, construction and railway sectors, with a particular focus on BIM and the contribution BIM can make. So Katie, great to have you along. Let me start off with some of these questions that we've got here. And this is a question for Jeff, if I may. Jeff, you mentioned that in England, the Geospatial Commission has been set up and is developing a national underground utility register, NUAR. When is this expected to be fully developed and rolled out?
Well, like I mentioned, two pilots have been completed, one in central London, one in the northeast. The one in northeast has actually been running for, I think, about 2 years. And it was very successful. I think the most remarkable thing about those two pilots is the degree of cooperation between local government and network operators, of the fact that they were willing to share information, including telecoms, which are usually the folks who really don't want to share their information for very good reasons. I mean, it's a competitive business. So those have been completed, relatively successful. The Ordnance Survey developed a system for the pilots to make it possible for information to be shared. It was kind of an upload and share kind of a process. I actually experienced that. I went to London to one of the NUAR meetings. I was on the NUAR advisory board, and I went to London, and actually it wasn't London. It was in the northeast of England, where I actually could see. I had a handheld, and I could actually see underground infrastructure. I could see and compare that to where handholds were and manholes and so on. Now, the process right now is that they're in the process of developing the requirements for the RFP. And I think they're very optimistic that the RFP will be released before the end of the year. I think Katie might have an update on that. But that means that people could be bidding on that very soon. And the next step, and then it'll be interesting to see how this is going to be implemented. It could be implemented on a national scale, in other words, for England and Wales, or it could be implemented regionally. In other words, have different regional systems for doing this. Maybe one for London or different parts of London, one for the Northeast, one for so on and so forth. But this is imminent. I mean, this is going to be happening very soon.
Okay, thanks for that, Jeff. Katie, would you like to come in and contribute to that and respond to Jeff? I think you're muted at the moment, Katie. Just unmute.
Yeah, let me have a go. you're self-muted at the moment, Katie. There we go.
There I go. It's my understanding that the opportunity to tender will actually be coming out in July.
Oh.
So that's the last I heard. So I am doing some work with Project Iceberg at the moment, which is supporting the Geospatial Commission on this. And we at the moment are developing a series of use case kind of scenarios, which we're going to use as a kind of, I guess, the community of utilities, consultancies across GB are going to use to present the case for the Geospatial Commission to perhaps develop their data models in certain ways, which kind of leads me on to a question. I don't know if that's going to be yourself, Jeff, or Ross answering this one. So I've just scribbled down some notes. So it's my understanding that at the moment, the data model that's being produced is a 2D data model. Do you think we as an industry should be challenging this, and how are other countries modeling their data where they've been successful? And should we be challenging the Geospatial Commission to make sure that the data that's produced is an intelligent model in the way that the Ordnance Survey Master Map Water Networks product is, and should it be integrated with the other Master Map data products?
Okay, I can start off on that. So I think it really comes down to looking at existing data and looking at new data. I mentioned Singapore. I could mention some other jurisdictions that are mandating that anything that goes in the ground has to be captured in 3D to centimeter accuracy. In other words, it's mandatory. When you put something in the ground, and I could go through the list of jurisdictions that are doing this, but Singapore is a good example. If you put anything in the ground before you close the trench, you have to capture it to centimeter accuracy. Everything new. So that means over time, you're going to be gradually building up 3D models. The reality is that for existing data, most of the existing data is 2D. But I know there are projects for pipelines, in particular transmission pipelines. It's called, it's basically called a cover survey, which means that they have a fairly good 2D model of what is on the ground, but they are now capturing 3D. So they're trying to improve the quality, in other words, improve the 3D from 2D. So I think the reality is that the future is definitely 3D. I'll give you another example, and that is there was a highway interchange project in Atlanta where they spent a couple of $1 million capturing the location of all underground infrastructure in 3D during the planning project. Before any design happened, they had a 3D model of everything. And it was clear from the 3D model that if they'd only had 2D, they would have assumed that they would have to move certain utilities. In 3D, they could see that they didn't have to move those utilities. So there is a significant value for 3D.
I'd like to contribute to that, because yes, I mean, 3D data is absolutely essential. If you haven't got Z depths and you only know where a pipe is in plan, then there's still a good chance that you're liable to hit it. So new data going forward, that's recorded in 3D because of the technology that we have. But existing data, like Jeff says, that's typically in 2D, fairly sketchy at best. However, we're still opening up trenches on that old network, and we should be getting Z depths. Now, we've recently run a hackathon with some young and very clever programmers who were charged with, here's a load of 2D data. This is straightforward mapping in 2D, and what can you do with it? Because we have got some occasional information showing maybe there's been a trial pit, some work done, and we have got some Z depth information. Now, of course, no one is naive enough to think that pipes always fall continuously from A to B and it's a continuous and predicted fall. But what they did, they said, well, acknowledging the fact that we can't possibly get it perfectly right, but what we can do, we can take as much 3D information as is available, and we can interpolate that data onto a 2D map and start to generate a couple of things. We can start to generate a 3D representation of the network, but what we can do, we can assume, and I know assumption is the mother of all disaster, but we can make some assumptions that a length of pipe probably runs fairly continuously, and we can add things called decorators to the 3D map that will represent and tell you the approximate depth. Now, having an approximate depth based on some intelligence is a darn sight better than having no information at all. And of course, if you take that information and you open a trench and you're within a few inches or feet of that particular utility, and you can correct it and improve upon it and store the data, then you've got that continuous replenishment of quality in the model. The technology that they use is very straightforward. It's open source technology, and it can be continuously improved upon. So once you get the momentum moving, and once you get enough people contributing to it, that model just gets better and better. And ultimately, we could potentially see old 2D data having additional value over time. But it's having everybody agree and have the momentum to do it. And like Ian said, it's what's in it for me. Either I don't die, I don't die because I don't hit a power cable, or there's cash in it by coming up with this particular idea, the avoidance of clashes. So there is some technology available, and we ought to drive and exploit it as best we can now.
Yeah. Guys, we've got a lot more questions here, and I know we're bang on the hour, so I'll say thanks very much for everybody for joining, but we'll carry on over to the lock-in if people want to join us. We have got a lot more questions. I think the discussion's only just started, so those that want to come along, please stay. But we are 1 hour up, so thank you. Can I just add to what you just said, Russ? One of the things that was essential was building infrastructure schemes, and I'm talking about transport infrastructure and commercial infrastructure, be them airports or whatever. In the main, information's captured and it's used for the duration of the project, but there was no receptor or end recipient that would take the information afterwards. And I think that's another thing that needs to be considered. Is having a responsible recipient that can take information. Now, what I mean by that is everything that's uncovered, because there's a significant amount of money spent in trial holding locations so that you can go to work and build what's been designed. Now, that information that's captured, certainly at the last time I looked, it still wasn't handed over to anybody. Maybe that's something the Geospatial Commission can take in hand and use, because it is. So if you think of all the infrastructure projects that we do around the country, and I'm not talking about new build installation, I'm talking about existing stuff where we've exposed services. There is a tremendous value in that, and I think if it was captured and shared, it would add another piece to the jigsaw that we don't have. Yeah.
Well, that goes for trial holes and boreholes. I mean, borehole information is massively valuable, but it doesn't get shared. Now, it just so happens that there is a very powerful database available where all borehole information can be stored and shared in the cloud. Yeah. But again, why, if I'm a company that's collecting this data, what's in it for me just to share it, apart from being, an altruistic thing to do? What's in it for me just to share that data? There needs to be some kind of, I believe, a government mandate that says if you open the ground, if you do a borehole, if you do a slip trench, you are mandated to save that data in some mechanism, and it needs to be a neutral mechanism, which is why I refer to the Centre for Digital Built Britain.
Yeah,
but you're absolutely right.
Sorry, if I can just jump in there. Sorry. It's my understanding that the Geospatial Commission are actually working with all the regulatory bodies at the moment, and they're all kind of housed in the same building down at Westminster. So the sort of water utilities, all those bodies, and I know that's going to be a bit of a struggle, but there are those discussions happening.
Well, yeah, I could just quickly add, when I was working for North Thames Gas, we were pioneers on a geographic utility information system, which formed the basis of NJUG, the National Joint Utilities Group. But that was a long time ago, and even today, I mean, I'm not so close to the utilities as I used to be, But even today, it seems that we haven't progressed so much. It's like gas pipes, for example. I still have a somewhat sad attraction to looking down holes where there are gas pipes, because what I used to do. And some time ago, I looked at, there were some gas works being carried out, and I noticed that the yellow pipes had brown lines running longitudinally along the pipe. And that caught my imagination. And I thought, is that some kind of metallic strip that they've decided to extrude with the pipe that could be connected via the heat world? Because when plastic pipes are assembled, there's a heat world. It's a metal loop with a connector. And I thought maybe what they've done is they've injected some kind of low-cost metallic element to it. And now, if you can expose a piece of gas pipe anywhere where there's a joint and you can get back on the heat world connectors, you can inject a signal and trace it. So I just said to the guy doing that, I said, that looks great. You've got some tracking mechanism. And he said, no, he said, we couldn't get pipes from our normal supplier, and these pipes have turned up with brown stripes painted on them. Nothing changes.
Yeah, but Russ, there is definitely, you can definitely buy a plastic pipe with tracer wire. I mean, what you suggested is something that people are trying to, some people are trying to do.
But no, you've only got to look at the rules of pipe on the roadside to know that that's not common, particularly when it gets to anything less than 2 inch. Nobody really cares. Right.
And then your other suggestion about boreholes is interesting, because Netherlands about 2 years ago mandated a shared database of borehole information. It's going to include 26 geotechnical variables. It started off with 3 groundwater variables, for example, and basically exactly what you said. If you drill a borehole, you have to share that information, so that anybody coming along and doing construction in the same area has access to the information that you captured when you drilled your borehole.
Yeah, I think I'm familiar with the company in the Netherlands that did that, and I think they're a recent Bentley acquisition, so I won't go there.
Can I just jump in here? We've got several questions coming from the attendees, and I'm conscious that we ask them before any of them leave. But I will say, if we don't manage to answer all of them and you've left, then I'll keep an eye on it and I will respond separately. So please keep the questions coming in. Okay, so the first one is hi Jeff, thanks very much for an interesting presentation. You mentioned a number of different approaches to sharing data. In the UK, we've always believed that providing the ability for searches to be made free of charge for users is essential to avoid any barriers to safe digging. What's your view on the different approaches across the world to charging those that are trying to work safely? And that's from Richard Broom.
Yeah, that's a very interesting question. You might have remembered that one of the things on my last slide that I was critical was some sort of viable business model to support stuff. You can come up with all sorts of wonderful systems, but there's always the question of who's going to pay for it. I'll give you an example. In the Netherlands, I mentioned the CLIC system, KLIC, which is basically an online one-call system. That costs you 32 euros. That costs construction contractors 32 euros for every week rest. So every time they go in and say, I need information, I'm going to dig in this area, they have to ante up 32 euros. In North America, all the one-call systems are free to the construction contractors, to the excavators. Doesn't cost them anything. But it means that the network utility operators have to maintain a fleet of vans, locators, or else contract it out, so it costs the network operators quite a lot of money. I mean, I worked with a relatively small network operator. It was a electric power utility for a city of about 1 million people, and I think they spent $1 million a year doing locates. They had 21 vans, they had 21 people running around the countryside, and so on. So it costs money. There are other models, and I'll mention France, where I mentioned before that they had a shared liability model. They also have a way of sharing information, and they have a different quality system. It's also ABC, but A means that you know where things are to 40 centimeters or better. B means 40 centimeters to 1.5 meters, and C means worse than 1.5 meters, or you don't know where it is, whatever. And based on that, they have come up with rules for how people pay for improving the location of stuff.
Yeah.
So for example, if I'm a network utility operator and I say, this is the location of this pipe, and I classify it as A, which means I know where it is to better than 40 centimeters. Somebody digs, you know, a meter away from that and actually hits the pipe because my data is incorrect. I, as the network operator, is responsible for paying for improving that information. Okay. And it works the other way. If I'm a contractor and I take this data and I dig and I hit the thing and it is actually where the network operator said it was, to within 40 centimeters, then it's my liability to pay for it. And then there's things in between where, you know, maybe it was and so on and so forth. So there's a lot of different ways to do this.
And there's also the opportunity to avoid Section 74s with prolonged time on site. I mean, you know, obviously, if a contractor is on site and there's a utility strike, he's going to be on site longer than was planned with the local authority, and he will end up paying a fine for that. So, you know, the utility alone should see value in contributing to that system, even if it's just because they're saving the potential or the actual cost of being fined. And those fines do run into the millions for the utilities, you know, all over England. So there is a strong reason for them to invest in that system.
I've just got a note that's coming from Andy Rhodes. Andy says the pipe with the brown strip on both water and gas is called barrier pipe. It is used where the ground is contaminated, so that it's useful to know but doesn't allow to trace. Which leads me to the next question I've got here from Lee Cartwright. Does the panel have any suggestions for the correct detection of existing plastic pipes within the ground? Anybody want to take that one?
I could suggest, I'll suggest some things, but I'm sure Russell will have some comments on it. For existing plastic pipes, inertial location is very good. Now you can't have any right angles. Okay, you know, it depends on the pipe network. You can't have right angles because your little pig won't go around the corners. That, you know, the company I know who does inertial, you can have pipe diameters that range from a few centimeters to a meter or two, and there's different devices for those different things. So that's one. Another one is acoustic locating. Acoustic locating will go down, it will go down 30 feet, right? You know, 10 meters. So that is something also that can be used for things that are not metallic. Ground penetrating radar will detect things that are non-metallic, but it really depends on the soil conditions. If you've got clay, it's not going to go down more than a meter or two if you're lucky. If you're in solid rock or something else, it can go down tens of meters. You know, so it really, you know, this is, I guess the simplest way to put this is there's no magic bullet. It really depends on what you're looking for, what the soil conditions are, how big it is, whether you have access to the pipe so that you can insert a pig, you know, that kind of thing.
Okay,
so you're right. I mean, the hardest thing to trace is a plastic gas pipe. There's not enough medium in the pipe to do anything with. The best you can hope for is to expose it and put an ultrasonic impact device on the pipe and try to listen to where you get the soundings. But it's really, really hard. This is why tracing wires either can be injected through an under pressure T perhaps with a device, but it's really hard.
Yeah. Oddly enough, my Russian doll story relates to plastic gas pipes, but I've still got some questions to go, so I'm not going any further with that one. I've got a question from Harry Parnell. Balfour Beatty Dartford Free Flow Project 2012, we used 3D GPR and processed into 3D, and then used for clash detection for the design coordination against survey, and had 974 high potentials which were programmed around or diverted. 3D is the way to go with PAS 128 and PAS 256 data requirements. Who would take that question? Is that Jeff? Is that for you?
Well, I'll start off, and I say I agree totally. I think he's absolutely right, and I'll leave it at that and let other people comment.
Well, the only thing I would add is that, you know, if you are getting data of a certain quality, then there is the opportunity these days to use machine learning to, a much faster way of interpreting that data and making some value from it. So machine learning capabilities to filter that data and improve it, that's growing. Every day that solution is getting better.
Yeah. The next question I've got here is from Steve Crossland, and it goes to what I said before about the jigsaw pieces, trial holes, and etc. Who is pulling all the jigsaw pieces together? Trial holes, as-built, found services. All this is happening today, but there's no drive to collate this valuable information. So I think we said that this could be something that the Geospatial Commission could potentially look at. We said that, didn't we?
Yes.
Yeah.
Yeah,
Katie, do you have any thoughts on that? The information that sits sort of outside of the new installation. So, as-built information, trial holes, and the like.
I'm sorry, I'm going to have to go soon, but I think other kind of information that I think needs to be thought about when it comes to new assets put in the ground are, and this goes back to what you were talking about, Russ, in terms of the digital twin. Are we looking at a kind of using asset classification systems such as Uniclass 2015? Which all the other major infrastructure projects in the UK are using at the moment. For example, East West Rail are looking to head down that track, High Speed 2. The Environment Agency are very, very kind of heavily invested in working with the MBS to kind of develop new sort of codes, etc. I think that's something that's not really being thought about. It's not just the geometry, but it's classifying all that data so we can have a national kind of picture of what's in the ground as well as what's above ground.
Okay.
Totally. If it's a digital twin, then the better the classification of the components recorded, the better the outcome. So 100%. That's why you need an intelligent, independent body to apply that sort of technology, which is, again, anybody that is able to build a digital twin of the quality of CDB. That's probably a body to use.
Mm-hmm. We got a question from Andy Rhodes. Andy, thank you. There's a question, it's a statement. GPR also depends on the size of the pipe at the depth you're looking at, as GPR can see in the real world 5 times the size of the wavelength, which equals the depth of the pipe, but the pipe needs to be greater than 10% the size of the wavelength to be seen. Right, I think I've got my head around that, but yeah. Any thoughts on that, Russ?
Absolutely none. The point is, though, that Birmingham University, with their Mapping the Underworld, took the best of all the detection equipment, mounted it together, and did some experimentation. The outcome wasn't massively exciting at the end of the day. It's still difficult with the technology that we have to, get accurate information about what's anything more than 3 foot underground. So I can't argue with the physics in that, but I see no better way.
Yeah, I would just add that I think right these days, if you talk to anybody who's doing underground locate, they use everything they can get, all the information they can get, even as-built that everybody knows are very generally unreliable. If they can get ground penetrating radar scans, if they can get EMI scans, if they can get acoustic information, if they can look at what's visible above ground and try to connect the dots, I think it is still an art rather than where you just use everything you can get.
I wouldn't mind betting that most of the gas vans and water vans out in the field still have the sounding poles with the hammer attachments, that you push through the ground until you hit something, just tap it to see what it is. I bet they still use those.
Yeah. Okay, well, I think we've exhausted all the questions, although I have got one other question here, which I'll ask. I'm not sure whether they covered this, but the NUAR, once it's in place, do we expect NUAR to reduce underground utility strikes in England, Scotland, Wales, Northern Ireland?
I'd like other people to respond to that, like Russ and Katie first, and then I'll respond to it.
Sure. Katie, I know you've got to jump off shortly, but you got any thoughts on that?
Absolutely. I think that's why the whole program is in place. I'm working on some projects at the moment where it's not just the cost of and the indirect costs of when a strike happens, but I'm seeing the cost of actually trying to acquire that data and not having any trust in that data. So it's then going to have to resurvey and resurvey and resurvey is just huge in the construction industry in the UK, I think. It's very, very difficult, as you alluded to before, Jeff, in getting sort of information from the different utilities, even for government projects. So it's just, and I've just seen it sort of 6-8 months trying to get hold of one particular data set for a very small geographic area. It's just very costly, just in that itself.
Yeah.
Over to you, Russ.
Well, simple for me. If there are high value projects like Heathrow, like Crossrail, then of course data location is incredibly important and there's money there to do it. But the vast majority of these strikes normally happen in the high street or down the road outside your house, which really, there's not enough money to invest in the everyday work to encourage the utilities to coordinate the data. So if it's a high value project, you can see that that's going to be part and parcel of the requirement spec. But anything less on a day-to-day basis, it's easier to break it and fix it than it is to record it and knock on doors and ask for information.
Yeah. I've got a question just before Jeff comes in. I'm just going to ask this question. Let's just state another question together. Thanks to Paul for asking this one. It's uncharted services, a real problem for I think the project he's working on. How can we push for better mapping? Jeff, do you want to come back on that one?
Okay. So let me answer the first one first. The question about whether NUAR is going to improve or reduce the number of incidents of underground damage. I would say there's no magic bullet for solving this problem. One thing is not going to solve the problem, and I'll give you two. Well, I've already talked about Heathrow, and I've also talked about Japan, and it was not simply implementing an automated one-call system. If you look at the CLIC system in the Netherlands, which is an automated one-call system, in other words, everything's on, all the utility data is in this database or accessible through this interface. You can go in, define a polygon, you can get all the information you need about what's supposed to be underground there. And the statistics have shown that has not reduced the number of incidents of underground infrastructure, number of strikes. Okay, it has made construction much more efficient. You can get information much more rapidly, but you still have the quality problem of the information. And a lot of 2D, a lot of the 2D underground existing 2D underground infrastructure data, location data, is poor. I'm trying to be polite.
Yeah.
Right. So I think this is an important step forward, and to me, the most important thing about NUAR is getting, I think you remember that when I talked about Japan, one of the top things they managed to do was collaboration, getting network operators, government agencies, contractors to talk to each other. And I think that is probably going to be the biggest value of the NUAR project, is getting people to start collaborate. It won't be instantaneously, there won't be an instantaneous reduction in number of incidents of underground, but I think it will provide the foundation for starting that process, a process of continual improvement where over time it will go down, just like aircraft accidents have gone down.
Yeah. And I've got a statement made by Andy Rhodes. NUAR can only reduce the number of known utilities getting damaged. There are many unrecorded utilities, uncharted, that are not on the record and won't be captured by NUAR until utility companies start coming out to identify unknowns and update the register.
Absolutely correct. Yeah, I'll just stop there. But Andy's absolutely correct.
It's absolutely right. Contract. When I worked for British Gas, contractors would, in some instances, measure the location of the gas main that they were laying. But if they encountered telecoms or water or power, and if I said to them, look, did you also record the position of the power cable? They said, no, it's nothing to do with us. And then backfill the trench, and it's lost. If I was there quickly enough while the ground was still open, I would make a note of the other utilities. But of course, the contractors are paid by the meter, paid by the pipe length. So all they're going to do is the bare minimum of non-construction work.
Absolutely. I mean, this is a classic problem of one call centers, right? So after you call a one call center, each of the network operators, electric power, gas, telecom, whatever, come out and identify their network. If there's any abandoned stuff there, it's not their problem, right? And the problem with in some jurisdictions, abandoned stuff automatically becomes the city council's problem. Right? In other words, if there's stuff there that no network operator claims it's theirs, then it becomes the city council's problem, which means it becomes the taxpayer's problem, right? So Andy's absolutely right. I mean, this is a really big problem, what to do about abandoned or infrastructure that you can't connect an owner to.
Yeah, we've got a lot of thank yous coming in from the attendees. A lot of guys want the slides. Yes, I will share the slides afterwards. They'll be available on video as soon as the thing's downloaded. But I suppose now we're nearly coming up to time. Now's as good a time as any to share my Russian doll story, which relates to gas. And I'll very quickly share this. I'll try not to bore you with semantics, but it started with, it was a project, an infrastructure project in the northwest of England, and there was quite a bit of demolition, Victorian properties. And once these properties were out of the way, the proper work started with earthworks, and it crossed lots of existing infrastructure, roads and underground services. And in the process of dealing with the underground services, there was a program to divert them. Now, when work started in earnest, you don't just go to work with big earth movers. You've still got to check what you've got on the ground, trial holes, as I mentioned earlier. And one particular location on one particular day, and it happened to be absolutely pouring down, it was freezing cold, as it usually is when you're in the ground. This service was cast iron pipe, and it was so old, there was layers and layers of rust around it. So I don't know whether it was put in the 1850s or whenever it was, but it was considered to be dead, and it said it had been abandoned on the drawing. But as responsible contractors, we don't take that at face value. So we do some investigations, and we find that there is no gas inside. So we carefully start to remove it. And inside, we find a 150 diameter polyethylene yellow gas pipe. And we do some investigations, and we ring the gas people, and the gas people say, yes, it's dead, it's fine, it can be removed. So again, careful contractors, being very considerate, we carefully remove it. But inside that, we find a 63 mil diameter polyethylene. So we, again, careful contractors, we carry out investigations, and we find that there's nothing in there. There's no leakage of any gas. So we carefully remove the outside skin, and inside that, we find a 1 inch or 25 mil diameter polyethylene, and it is live. So we call the gas board back, and on 4 separate occasions, they told us it had been abandoned and there was nothing there. But I have to say, I'll take my hat off to how industrious the individuals were that probably installed this over time, not digging up footways, not creating nuisance, proper industrious, but it was a hazard nonetheless. Now, there is a risk still with small services, but it just goes to show. I mean, I call that the Russian doll incident, and I've dined out on that for a long time, and that's where the little picture came from at the beginning. But it's just that's just one of many that anybody that works in this in civils or any part of the industry where you're involved in interfacing the ground and making changes, you come across situations like that all the time. And it's to do with records, and nobody had any records that service pipes were installed in service pipes, and it just makes me smile every time I think about it. The unfortunate thing is I don't have any of the photographs because they would have made some classic shows for today. But anyway, there we are. So just as closing thoughts, anybody got anything they'd like to say? Ian, I'm sorry Katie's had to leave, but Ian, you got any thoughts before hand it over to Jeff and Russ to close out?
No, just purely to say thank you very much to Katie, Jeff and Russ. Some really, really good insights here on what's going on and what the problems are that are being faced. And it certainly seems to me that not only do we need that national digital underground twin, as it were, but we need to have a consistent and consolidated way of recording that and some way of enforcing people to record it when they find it. The only thing I can worry about there is even if the rules are in place, oh, I can't see that in the ground, so therefore I don't have to record it, might be there. But then you might be able to put some sort of thing on that in the fact that if somebody else strikes a live service in that area that you haven't recorded because you were the last person to dig the hole, it's your responsibility. Then suddenly people might actually start sitting up and taking that responsibility seriously if they know that they might go to jail in 10, 15 years' time if they haven't done the recording correctly. And I think it is down to that enforced responsibility in some way. But some awesome stuff. Thank you very much, you guys. What I will do is I shall hand you back to Stuart, but I shall also wish those of you who stayed on this long a very, very good weekend. Have a great time, stay safe, and don't do anything that I wouldn't.
Cheers, Ian.
Thanks, Ian. Anything from Jeff? Anything from Russ?
Yeah, I'll just add that I think what is happening in England and in Scotland, and is what's happening in Colorado and what's happening in Montana and what's happening in Singapore and what's happening in France. I think it signals that something is actually being done about this. After all this time, I think we are really starting to make some progress on this, and I'm really full of admiration for what the Geospatial Commission is doing in the UK.
Yeah, absolutely. And if that results in a national joint utilities digital twin, then good luck going forward.
Yeah, that'd be cool. Very cool.
Thank you. Well, just to close out, continue the conversation offline through the various channels. The presentation will be made available as soon as it's downloaded. I will post it to the COMIT website, and you'll also get a notification through the GoToWebinar facility, which will link you back to today's session. So thanks again, everybody. Really appreciate all the effort everybody's put in. Thanks for the questions. Thanks to the attendees for joining us, and have a great weekend, everybody. Thank you.
Yep, thank you, everybody. Bye-bye. Stay safe.
Bye.
Be in touch. Bye-bye.